Okay, in this example, we're looking at composition of functions. Now, composition, if you remember, is an operation that's not commutative. In other words, if you compose two functions, f and g, and then turn around and compose g with f, you should not expect to get the same answer unless they're two very special functions. Here we've got an example. We're given that f of x is x squared plus 1, g of x is x minus 3. We're asked to find part A, f composed with g, part B, g composed with f, C, f composed with g of 2, D, g composed with f of 2, and then finally part E, g composed with g composed with g. We're doing composition 3 times in that problem. Alright, now for part A, f composed with g means f of g of x. Now, f composed with g means f of g of x, and this means f of g. What is g? G is x minus 3. Okay? Now, what does this notation mean? Well, it means that in this particular example, everywhere we see a x in f, we're going to put in x minus 3 for that f, and do whatever's done to that x to x minus 3. So that turns into f is x squared plus 1, so we're going to have x squared, this is going to be x minus 3 squared plus 1. Okay, and now for me that's really far enough if you're all you're after is composition. But in this case, looking down the road, we need to find f composed with g of 2, so let's go ahead and simplify that out. Now, x minus 3, quantity squared, if you remember, that means x minus 3 times x minus 3. When you square that out, you'll get x squared minus 6x plus 9, and then we still have the plus 1 on there. Combining like terms gives you x squared minus 6x plus 10. So there is f composed with g. Now let's look at g composed with f. In this case, f is now our interior function, where in this example, g was our interior function. So g composed with f means g of f of x. And what is f of x? F of x is x squared plus 1. And just like before, composition, the rules don't change. In g, everywhere we see an x, we're going to put in x squared plus 1. Well, g is really a pretty simple function. It's just a linear function, x minus 3. So this turns into x squared plus 1 minus 3. That's replacing x with x squared plus 1. Then, here, simplifying that's no big problem. This turns into x squared 1 minus 3 gives you negative 2. So there are f composed with g and g composed with f. Now let's look at f of g of 2. We can do that 2 different ways. I'm going to show it to you on this example. Way 1 would be to evaluate g of 2. G of 2 would be x minus 3, or 2 minus 3, which is negative 1. And then what this means is f composed with g of 2 means f of, what is g of 2? Negative 1. That gives us f of negative 1. F is x squared plus 1. Well, 1 squared plus 1, or negative 1 squared is 1. 1 plus 1 is 2. That's way 1. Way 2 would be to take the expression that we got for f composed with g and evaluate that at 2. In that case, that would give us 2 squared minus 6 times 2 plus 10. Now 2 squared is 4. Negative 6 times 2 is negative 12 plus 10. And hopefully we'll wind up with a 2 here. 4 minus 12 is negative 8. Negative 8 plus 10 is 2. So we get the same answer, which is a good thing because it's the same problem. We're just doing it a different way. Now, For g composed with f of 2, I'm just going to use the second way there. We know that f, or g composed with f of x is x squared minus 2. So we just want to evaluate x squared minus 2 at 2. That gives us 2 squared minus 2, which is 4 minus 2, which is 2. Okay? Now, the tricky one here is g composed with g composed with g. It's kind of hard to keep track of what's your interior function, so I'm going to try and use green chalk for the interior function. G composed with g composed with g means g of x. This g and this g are the same, this g and this g are the same, and this g and this g are the same. So for the very first one, this g right here is my interior g. So I want to make it green. And now you put in the numbers of the functions, whatever it happen to be. In this case, g of x is x minus 3. So what that gives me is g of x minus 3. That needs to be in green because it's my interior function. Okay. Now, what does that mean? Well, this means that if we just ignore this exterior g, we evaluate g at x minus 3. In other words, everywhere we see an x and g, we're going to put in x minus 3. So that gives me g of, now, g is still x minus 3. So that means we're going to take x minus 3 minus 3. Okay, the green x minus 3 and the green x minus 3 are the same. And we can simplify that. That turns into g of x, negative 3 minus 3 is negative 6. So that gives us g of x minus 6, all right? Now, what does that mean? Well, that means that we evaluate g, which is x minus 3, at x minus 6. In other words, everywhere we see an x in g, we're going to put in x minus 6. So I'm going to rewrite this. I'm going to write this as g of x minus 6. And the only thing I'm changing there is the color. I'm changing the x minus 6 here to a green x minus 6 to illustrate what's going on. Now, that gives me x, and now my x is x minus 6, and then I have the minus 3. And then combining like terms, this turns into x minus 9, which is our final answer. All right, well, so let's go over this one more time because it is kind of tedious. G composed with G composed with G. That means G composed with G composed with G. Saying the same thing, doing the same thing, just writing it a different way. That's what a lot of math really is. Now, remember, composition means that realistically you're taking the range of one function and you're using it as the domain for another. In this case, it's all the same function. So, what is g of x? G of x is x minus 3. So we're going to put x minus 3 in for this. And then everywhere we see an x in g, we're going to put in x minus 3. And that's what we did. G is still x minus 3, so we got x minus 3 for our x minus 3, and then minus another 3. And then, combining like terms here, negative 3 minus 3 is negative 6. And then we want to do composition yet one more time. That's going to be g of x minus 6. So that means that everywhere in g we see an x, we're going to replace it with x minus 6. And that's what we do here. X minus 6, that is my x, minus 3. And then combine like terms, you get x minus 9. Okay? Well, I hope that clears some things up for you. And that is composition of functions. Thank you.